Hello, welcome back. In this class, we are going to look at Bayes' theorem. Sorry for this. Okay, all right. We are going to look at Bayes' law, which we also call Bayes' theorem. Very, very important formula in the world of probabilities, and it was developed long time ago by Thomas Bayes in 18th century. So it is something that has been developed long, that a lot of research has been done or worked on, but it is still very applicable concept of probabilities that we all use in our day-to-day life, and also we apply it in those who want to grow into data science and machine learning. All right. It assumes that we have some prior information. Okay, for instance, if I'm selling, let's say, insurance cover, and I come at your place to sell your insurance cover, I can calculate the probabilities that you buy this cover, right? From the general population, I can calculate the probability that you buy the cover I'm selling. But if I get the information that you have a car, or you have a passenger vehicle or a car vehicle, then I can calculate the probability of you buying the product I'm selling. A better probability and a different probability, because I've already known something about you. If I'm selling a book and I've known you have a high school student and I'm selling a high school textbook, then you are at a better chance perhaps of buying my book. So there are different conditions that change the situation that we are currently having. If I have calculated the general probability of something happening, then if I've known or if I got another information, then I'll be at a better position of calculating different stuff, and those we apply it in Bayes' theorem. All right, great. In the world of probability and application of probability to machine learning, we have a problem. What is our problem? Our problem is same x's do not give to same y's. Same x's do not give to same y's. What do I mean? People with the same characteristics do not give me the same result. For instance, if I want to give out loan, okay, the person whose income is the same, whose gender is the same, whose region is the same, but someone decide to pay back the loan on time, another one decide to default. All right, so those are the challenges that we face in our everyday life. If I'm selling a policy, the people with the same characteristics, someone buys, someone fails to buy. If I'm doing some research on the justice stuff and someone has the same characteristics of another one, and one of them decides to buy, not buying. Now, some of them found guilty, some of them not found. I don't know if it makes sense anyway. So those are the issues that we interact with in our everyday life. Same x's, different y's. And those are something that makes us to teach our machine. And we have to learn that machine doesn't do something out of something that you cannot do. It does something that you have done or something that you have trained it to do. Anyway, I'm not teaching machine learning in this class. Same x's, different y's. And that is why you don't want to have, for instance, you don't want to have zeros and ones, right? Like you buying, not buying, or repaying, defaulting. you can't decide this. Instead of having zeros and one, you have values in between here for you to make a better decision. All right, maybe values towards zero is that they are buying. Values towards one, they are not buying. Values towards zero might mean defaulting. Values towards one might mean repaying the loan on time. Values towards zero will be a girlfriend not accepting my proposal. Values towards one means them accepting my proposal anyway. Okay, interesting example, right? Once again. All right, now with this brings the interest of probabilities and makes us to think of probabilities all day, every day. Again, something that I would want us to touch on is when we were introducing probabilities, we talked of how does Google identify spam file. Okay, how does the Google identify the spam? And we have mentioned that Google identifies spam by using maybe how the words are arranged, maybe looking for a specific or certain word like congratulations, you have won, and the stuff. And then there is no 0 and 1, right? Because if it is 0 and 1, but the decision is of course 0 and 1, because you decide to give, you decide to not give, they decide to buy, they decide not to buy, they decide to you decide to put it on a spam, you decide to put not in spam. Of course the decision is 1 and 0, but the probabilities that are there is not 1 and 0. For instance, when Google decide to put a certain email on a spam section of your address, it is not very sure. Of course they have their own threshold probabilities. Let's say if the threshold of this email becomes or they set it at 0.5, the probability of it being a spam is not 0.5 actually, maybe 0.8, then let's categorize this email as a spam. But you can sometimes meet some email, perhaps your friend is congratulating you for being promoted in a job and they have spammed it, and of course you have to mark it as not a spam so that they realize or they make some better decisions in the future, because how many emails they have marked as spam, but the respondent or recipient mark the email not as spam. So in nutshell, there is a lot of application in Bayes' law and the probabilities. It is all about our effort of trying to apply these laws. All right. So in our next class of still on Bayes, I'll talk of a little application, and we touch on some few calculation. Let's say you went to VCT center and you had a positive result. So from VCT, the result that you received is you are positive. How much should you worry? Of course, this kit has been created by someone. There must be some mistakes. How much should you be worried if your result turns out to be positive? I hope this is helpful. See you in our next class. Ciao, ciao.